So see the first line, serial.begin 9600. It means serial communication is began between your PC and the Arduino with a 9600 kbps baud rate. While not serial, semicolon, it means until and unless serial communication is not initialized between your devices, just let it nothing happen. So after that, then serial SIM-800.begin. So serial SIM-800 is our customized and our serial communication, manually made serial ports to communicate with our GSM module. So it is also initialized with a baud rate of 9600 kbps, and this connection is occurring between your Arduino Nano and your GSM module. So after that, a delay of 1 second has been given, delay 1000, which means a delay of 1000 milliseconds. And then on your serial monitor, you just printed setup complete, which means after covering these instructions, after following these instructions, it will show you that the setup is complete. Then I have given some instruction which is 80 plus CSMF equal to 17,167,0,0/r/n. Well, if you don't write this piece of instructions, you may give it a try, but the thing that will happen is when you will receive a message on your cell phone, it will be completely blank. You will say you will be sending a hello or a text or any text from here, but that text will not appear in your cell phone. The message will be a blank one. Let's move to the next line. So in this line, you see that the 80 plus CMGF equals to 1/r/n, which means by default, your GSM module or your Arduino, they are set to the protocol data unit mode or the PDU mode. So whenever we try to send some text, it is converted to any other group of special characters, and it is completely not readable and not understandable by us. So to change it to the text mode or to the ASCII mode, we use this set of instruction 80 plus CMGF equals to 1/r/n. So the next line is 80 plus CMGS equal to, then see in this format, inside this we have included the recipient number over here. Here I have included the recipient number. So after that, after include the recipient number, in the serial monitor, it returns you an arrow to enter the body of the message or enter the lines of the message you are trying to send. Thus, after that, after a delay of 1 second, here to that serial port, to the 8th and the 7th pin of a microcontroller, we are writing a hello. Well, this is the body of our message that needs to be sent. And after that, it needs to be terminated with Control Z, but here by default it was PDU, protocol data unit, but by this set of instruction 80 plus CMGF equals to 1/r/n, by using this instruction we changed it to ASCII mode. Thus we need to send the ASCII code or the ASCII value of the terminating character, which is card or character value of 26. So it sends a line ending, and after that on the serial monitor we have written that serial.println sent. So when the message will be sent, it will show sent text in our serial monitor. So now just let's run. So see, nothing is inside the void loop because nothing needs to be happen repeatedly over here in this piece of code. So now just let's run it and give it a try. See. So it's nice. You are now receiving SMS from your GSM module. So it's a great